Hello there, and welcome to the Sleepy Facts channel. I'm so glad you found your way here. Maybe you had a long day, or maybe you're the kind of person who likes falling asleep to moonlit mysteries rather than counting sheep. Either way, tonight's journey is for you. Let your mind relax, your breathing slow, and your body grow light as shadows lengthening across a forest floor at dusk. Because tonight, we're exploring nocturnal animals, those creatures who wake when we sleep, living secret lives in darkness. We'll drift from silent owl wings to glowing fireflies, discovering how these twilight dwellers navigate a world without sunlight. Some of what you hear tonight may surprise you, or at least spark curiosity as you drift off. Before we begin, if this helps you unwind, consider liking and subscribing, one sleepy soul at a time. Now, let's begin. The barn owl flies through complete darkness without making a sound, its specially adapted feathers breaking up the turbulence of air flowing over its wings, creating flight so silent that prey animals cannot hear the owl's approach, even when it passes mere inches overhead. The leading edges of the owl's primary feathers bear a comb-like structure with tiny serrations that disrupts the air before it can create the whooshing sound that other birds produce in flight, while the trailing edges feature soft fringes that further dampen any remaining noise, and the velvety surface texture of the feathers absorbs sound vibrations that would otherwise announce the predator's presence. This silent flight allows the owl to hunt using sound alone, listening for the faint rustling of mice moving through grass, the owl's hearing being so acute that it can pinpoint prey location in three-dimensional space using only acoustic cues, calculating distance and direction from the tiny sounds that escape detection by human ears. The owl glides through the night like a ghost, its wings beating in absolute silence, the bird being invisible to its prey not because it cannot be seen in darkness but because it cannot be heard even when directly above. This adaptation being so effective that barn owls can hunt successfully in complete darkness, where vision provides no information whatsoever. The silent wings carry the owl across fields and through forests, the bird being a phantom of the night, a whisper given form, moving through darkness with the quiet grace of falling snow. The owl's face functions as a sound-collecting dish, the heart-shaped facial disc channeling sound waves toward the ears with remarkable efficiency, the feathers arranged in precise concentric circles that act like a radar dish made of soft plumes. The owl's ears sit asymmetrically on its head, one ear being higher than the other. This vertical offset allowing the owl to determine the elevation of sounds in addition to their horizontal direction, creating a three-dimensional acoustic map of the environment that tells the owl exactly where a mouse is located, even in pitch darkness. The facial disc feathers can be adjusted through muscle control, the owl fine-tuning its sound reception by changing the disc's shape, focusing sound from particular directions while filtering out background noise, the disc functioning like a movable satellite dish that the owl aims toward interesting sounds. The ears themselves are hidden beneath the facial disc feathers, being merely openings on the sides of the skull, covered by specialized feathers that protect the ear canal while remaining acoustically transparent, allowing sound to pass through unimpeded. The owl processes sound with extraordinary precision, the bird's brain containing specialized neural circuits that compare the timing and intensity of sounds arriving at each ear, calculating location with accuracy that allows the owl to strike prey it has never seen, the talons hitting their target with precision that would be impressive even with perfect vision. The owl's face is not just a feature, but a sophisticated sensory instrument, every feather positioned according to acoustic principles, the entire structure being an evolutionary masterpiece of sound collection and processing. The bird, wearing a biological sound telescope that reveals a hidden acoustic landscape humans can barely imagine. The owl's eyes are enormous relative to its skull, occupying so much space that the eyeballs cannot move in their sockets, the owl needing to turn its entire head to look in different directions, though this limitation is compensated by the owl's remarkable ability to rotate its head through 270 degrees. The eyes are not spherical like human eyes, but rather tubular. This elongated shape maximizing the eye's focal length and allowing more light to be collected and focused on the retina, creating vision that functions well in conditions that appear completely dark to humans. The retina contains an extremely high density of rod cells, the light-sensitive receptors that function in dim conditions, while having relatively few cone cells that provide color vision but require bright light. The owl essentially sacrificing color perception for enhanced sensitivity to movement and detail in darkness. The owl can see in light levels 100 times dimmer than the threshold of human vision, detecting prey animals moving through grass on nights that seem completely black to human observers, though even owls cannot see in absolute darkness and rely on hearing when no light exists. The eyes contain a reflective layer called the tapetum lucidum behind the retina. This mirror-like structure, reflecting light back through the retina a second time, effectively doubling the eye's light-gathering efficiency, creating the eye shine that appears when lights illuminate owls at night. The owl's gaze seems to penetrate darkness, the large, forward-facing eyes creating excellent depth perception through binocular vision, the bird's visual system being optimized for detecting movement and gauging distance accurately enough to intercept prey in flight through cluttered environments. The eyes being windows into a world illuminated by starlight and moonlight that humans experience as darkness. The owl's hunting strategy combines patience with sudden explosive action. The bird perching motionlessly for extended periods while scanning the landscape below for any sign of movement or sound, then launching into silent flight when prey is detected, approaching on whisper-quiet wings before striking with talons extended. The owl's legs are covered with feathers down to the toes, this insulation protecting against cold, while also muffling any sound the owl's movement might produce. The bird being silent from wingtip to talon, every aspect of its anatomy supporting the stealth that defines its hunting method. The talons possess remarkable gripping strength, the owl's foot closing with enough force to instantly subdue prey animals much larger than what one might expect, given the owl's modest body weight. The grip being so powerful that owls sometimes struggle to release prey once seized. The talons locking closed through a ratcheting mechanism that requires conscious effort to open. The owl swallows small prey whole, the powerful digestive system breaking down flesh while leaving bones, fur, and feathers undigested, these indigestible materials being compressed into pellets that the owl regurgitates hours after feeding. These pellets, accumulating beneath favorite perches and providing researchers with detailed records of the owl's diet. The owl's hunting success depends on all its adaptations, working in concert, the silent flight allowing approach, the acute hearing providing target information, the powerful vision confirming prey location, and the strong talons completing the capture, each element being essential and the entire system being refined through millions of years of nocturnal hunting, the owl being perfectly adapted to its role as nighttime predator, a creature built specifically for finding and capturing prey in darkness. The bat navigates through complete darkness using echolocation, emitting high-frequency sounds, and listening to the returning echoes to create an acoustic image of its surroundings. This biological sonar being so sophisticated that bats can detect obstacles as thin as human hair while flying at full speed through cluttered environments. The bat produces echolocation calls in its larynx, these sounds being extraordinarily loud, often exceeding 120 decibels if measured near the bat's mouth, though most of this sound energy exists at ultrasonic frequencies above the range of human hearing, making the bat's acoustic world largely inaudible to us despite its intensity. The bat emits these calls through its mouth or nose depending on species, many bats having elaborate nose leaves or facial structures that shape and direct the outgoing sound beam, focusing acoustic energy in particular directions, much as a flashlight focuses light, allowing the bat to scan its environment by moving its head. The returning echoes provide remarkably detailed information, experienced bats being able to distinguish different insect species based on the pattern of echoes their wing beats produce, detect the texture of surfaces, and even determine whether prey is moving toward or away based on Doppler shifts in echo frequency. The bat's ears are often enormous relative to its body size, these oversized pinnae collecting faint echoes and channeling them to the ear canal. Many bat species having mobile ears that can be aimed independently, allowing the bat to track multiple sound sources simultaneously. The bat's brain processes this acoustic information with extraordinary speed. The entire cycle of emission, echo reception, and flight adjustment occurring in milliseconds, allowing the bat to pursue flying insects through complex aerial chases in total darkness. The bat creating an acoustic world as rich and detailed as the visual world that diurnal animals experience, sound being transformed into spatial perception through neural processing that remains mysterious to researchers. The bat's echolocation calls change dramatically depending on what the bat is doing. The calls becoming louder, shorter, and more rapid as the bat closes in on prey. This acceleration of call rate being called the terminal buzz and sounding like a rapid-fire burst of clicks if slowed down into the range of human hearing. During cruising flight, when the bat is simply navigating, calls might occur only a few times per second, each call being relatively long in duration, with the bat having time to listen to echoes returning from distant objects before emitting the next call. As the bat detects something interesting and begins to investigate, the call rate increases and the calls become shorter, the bat trading long-range detection for more rapid updates about changing positions as it approaches the target. In the final moments before contact, the call rate may exceed 200 calls per second, the individual calls becoming extremely brief, the bat obtaining a nearly continuous stream of information about the prey's position and movement, adjusting its flight path in real time to intercept the target. This acoustic behavior is entirely automatic, the bat's nervous system modulating call production without conscious thought. The pattern being as natural to the bat as visual scanning is to a human looking for something, though the sensory world the bat experiences remains foreign to human imagination. The bat exists in an acoustic space that updates many times per second, the world being revealed through sound rather than light, distance being measured in echo delay rather than visual perspective, the bat's sensory experience being so different from human perception that understanding what it is like to be a bat challenges our ability to imagine alternative forms of consciousness. The bat's wing structure differs fundamentally from bird wings, being formed from stretched skin membranes supported by enormously elongated finger bones. This arrangement, creating a wing that is more flexible and maneuverable than the rigid feathered wings that birds employ. The thumb remains short and clawed, protruding from the front of the wing and being used for climbing and manipulating food, while the other four fingers extend to remarkable lengths, each one being longer than the bat's body and forming the structural support for different sections of the wing membrane. The membrane itself is living tissue containing blood vessels, nerves, and muscle fibers that allow the bat to adjust wing shape and tension in flight, this active control of wing properties, allowing maneuvers that would be impossible with passive wing surfaces. The tail membrane stretches between the legs and often includes the tail, creating additional lifting surface and being used as an aerial rudder and as a catching net for insects. Many bat species using this tail membrane to scoop insects from the air, then retrieving the captured prey with their mouths while still in flight. The wing membrane is extraordinarily thin, sometimes being less than 1/10 of a millimeter thick, yet being remarkably tough and healing quickly when damaged, small tears being common and repairing within days without apparent impairment to flight. The bat's flight is energy efficient despite the rapid wing beats, the flexible wings allowing the bat to generate thrust on both downstrokes and upstrokes through subtle changes in wing shape, this two-part power stroke being more efficient than the single power stroke that bird wings provide. The bat flies through darkness with confidence, the wings responding instantly to the bat's intentions, the flight being graceful despite appearing erratic to human observers, each twist and turn being precisely controlled, the bat being as comfortable in three-dimensional aerial space as terrestrial mammals are on level ground. The bat's roosting behavior reveals social complexity. Many species living in colonies containing thousands or millions of individuals. These aggregations roosting in caves, hollow trees, or man-made structures where darkness and shelter provide protection during daylight hours. The bats hang upside down using specialized tendons that lock their toe claws in place. This inverted posture, requiring no muscular effort to maintain, allowing bats to sleep securely while suspended, their body weight pulling the tendons tight and keeping the claws closed without the bat needing to consciously grip. The upside-down roosting position also facilitates takeoff, the bat simply releasing its grip and falling into flight, gravity providing the initial acceleration needed for the wings to generate lift, this being particularly important for species that cannot easily launch from level surfaces due to their wing structure and proportions. Colonial roosts maintain surprisingly stable temperatures despite external weather fluctuations. The mass of bat bodies generating heat that warms the roost, while evaporative cooling from the bat's breath and skin prevents overheating, creating a microclimate that reduces the energy bats must expend on thermoregulation. The social interactions within colonies include communication through vocalizations, scent marking, and physical contact, mothers recognizing their own offspring among thousands of similar young through distinctive calls and individual scent. This recognition being essential because young bats cannot yet fly when mothers leave to hunt and must be relocated upon the mother's return. The colonies pulse with the rhythm of night and day, thousands of bats exiting simultaneously at dusk in spectacular swirling streams that flow from the roost entrance like smoke, then returning before dawn to pack themselves into every available space, hanging in clusters so dense that individuals touch on all sides. The colony being both a social group and a survival strategy that provides thermal benefits and safety in numbers. The hedgehog emerges at dusk to forage through gardens and hedgerows, its nocturnal lifestyle allowing it to avoid competition with diurnal insectivores, while also reducing exposure to predators that hunt by day. The hedgehog being active through the night and returning to its nest before sunrise. The hedgehog's covering of spines provides remarkable defense, these modified hairs being stiffened with keratin and having sharp points. The spines covering the animal's back and sides, while the face and underside retain soft fur. When threatened, the hedgehog rolls into a tight ball, specialized muscles pulling the spiny skin down over the vulnerable areas, creating a sphere of spines pointing in all directions. This defensive posture being so effective that few predators can penetrate the spiny armor. The hedgehog being able to maintain this position for extended periods while waiting for danger to pass. The hedgehog navigates by smell more than sight, its long snout constantly sniffing the ground while it shuffles through leaf litter searching for invertebrates. The hedgehog's nose being sensitive enough to detect beetles and worms hidden beneath soil and vegetation. The hedgehog produces various sounds, including snuffling while foraging, loud snorts when startled, and surprisingly vocal squeaks and grunts during social encounters. These vocalizations being common in areas where hedgehogs are abundant. The sounds of hedgehogs foraging being a characteristic feature of nighttime gardens. The hedgehog's metabolism slows dramatically during winter. In cold climates, the animal entering hibernation for several months. This dormancy, allowing survival when insect prey becomes scarce, and when exposure to cold would otherwise require unsustainable energy expenditure. The sleeping hedgehog's body temperature dropping to nearly match its surroundings, its heartbeat slowing to a fraction of the normal rate. The animal being barely alive, but using so little energy that its autumn fat reserves can sustain it until spring warmth triggers awakening. The firefly is not a fly but a beetle, its bioluminescence being produced in specialized organs in its abdomen. The light being created through a chemical reaction that is remarkably efficient, with nearly 100% of the energy being released as light rather than heat, making firefly light the most efficient light production known to science. The light-producing reaction involves a chemical called luciferin that combines with oxygen in the presence of an enzyme called luciferase. This reaction, producing a high-energy molecule that releases energy as visible light when it returns to its ground state. The firefly controlling the flashing by regulating oxygen supply to the light organ. Different firefly species produce different flash patterns. These patterns, serving as species recognition signals that allow fireflies to identify potential mates of their own species. Among the many firefly species that may fly in the same area, each species having a characteristic rhythm, duration, and color to its flashes. The male fireflies typically fly while flashing, their lights tracing paths through the darkness, like tiny yellow aircraft navigation lights, while females usually remain on vegetation, watching the males and responding with their own species-specific flash patterns when they see a suitable male. The flash communication creates a conversation, the male flashing his pattern, the female waiting a precise interval then responding, the male orienting toward the response and flashing again. This exchange continuing as the male flies closer until he locates the female and mating occurs. The firefly's light seems magical on warm summer evenings, hundreds of flashing insects transforming lawns and forests into fairylands of moving lights, each flash being a message of love and life. The collective display being one of nature's most enchanting phenomena. Fireflies writing poetry in light across the darkness, their gentle glows speaking a language that predates human words. The lunar moth flies through darkness on wings that span 4 to 5 inches. These pale green wings bearing long trailing tails and eye spots that may confuse predators. The moth's coloration seeming to glow with an inner light when illuminated by moon or lamp. The adult lunar moth cannot eat, having no functional mouthparts, living only 1 week, during which its sole purpose is reproduction. This brief adult stage being the culmination of a year-long life cycle spent mostly as a caterpillar. The adult being beautiful but ephemeral, a creature living on borrowed time and stored reserves. The moth's antennae are extraordinarily sensitive to pheromones. Male moths being able to detect female scent from miles away. The feather-like antennae containing thousands of chemical receptors that bind to pheromone molecules, even a few molecules being sufficient to trigger navigation behavior that leads the male to the female. The lunar moth rests during the day with wings spread flat against tree bark, the green coloration providing camouflage among leaves, the moth remaining motionless unless disturbed, conserving energy for the night's flight when mate-seeking becomes possible. The moth's wing scales create the color through microscopic structures rather than pigments. These structures scattering light in ways that produce the characteristic green hue, the physical basis of the color, meaning that the wings maintain their beauty even after the moth dies, unlike pigment-based colors that fade. The lunar moth represents transformation and transience, the animal spending most of its life in caterpillar form, eating and growing, then entering a cocoon where radical metamorphosis reconstructs the caterpillar's body into moth form, then emerging for 1 glorious week of flight and reproduction, before dying, the moth being a reminder that some beauty is brief, that life contains stages of preparation, transformation, and brief flowering, the lunar moth being perfection that exists for only moments, before fading like moonlight at dawn. The raccoon possesses remarkably sensitive forepaws, these hand-like appendages containing more sensory receptors than almost any other mammal. The raccoon's sense of touch being acute enough to identify objects without seeing them. The animal frequently manipulating items underwater, where vision provides minimal information. The raccoon's characteristic behavior of apparently washing food is actually sensory exploration. The raccoon using water to enhance the sensitivity of its paws, wet skin, conducting tactile information more effectively than dry skin, allowing the raccoon to gather detailed information about food items through touch alone. The whiskers around the raccoon's face and on its wrists provide additional sensory input. These specialized hairs detecting air currents and physical contact, helping the raccoon navigate in darkness and detect obstacles or prey that it cannot see. The raccoon's intelligence is remarkable. the animals being capable problem solvers who can remember solutions to challenges for years. Raccoons trained to open locks, remembering the technique for at least 3 years without practice. This cognitive ability making raccoons successful in urban environments where adaptability and learning provide advantages. The raccoon's nocturnal foraging takes it through diverse habitats, the animal being equally comfortable climbing trees, swimming through streams, and investigating human structures. This versatility making raccoons among the most successful mammals in human-altered landscapes. The distinctive facial mask may reduce glare and enhance night vision. The dark patches around the eyes functioning like the eye black that athletes wear to reduce sun glare. Though in the raccoon's case, the benefit would apply to moonlight or artificial light that might otherwise impair dark-adapted vision. The raccoon shuffles through the night, its sensitive paws investigating everything they encounter. The animal being curious and thorough, examining the world through touch, the raccoon's paws being instruments of exploration that reveal secrets invisible to the eye. The opossum is North America's only marsupial, carrying its young in a pouch like kangaroos do. Though the opossum's reproductive strategy includes producing far more offspring than it can successfully rear, often giving birth to more than 20 young, though the mother has only 13 nipples in her pouch. The tiny newborns, called joeys, are barely developed at birth, each being about the size of a navy bean, blind and barely formed, crawling from the birth canal to the pouch through instinct alone. This journey being perilous, with many newborns failing to reach the pouch or find a nipple. Those that successfully attach to a nipple remain fixed there for weeks, drinking milk continuously while completing their development within the protective pouch, eventually growing large enough to venture out, though continuing to return to the pouch and to nurse for several more weeks. The opossum's famous behavior of playing dead is not voluntary acting but rather an involuntary response to extreme fear. The animal entering a catatonic state where it falls over, becomes limp, opens its mouth with tongue hanging out, and releases foul-smelling fluid from anal glands. This death-feigning being so convincing that predators often lose interest and leave, allowing the opossum to recover and escape. The opossum is immune to many snake venoms, including that of pit vipers. This resistance allowing opossums to hunt and consume venomous snakes without being harmed, the immunity being provided by a protein that neutralizes toxins. Researchers studying opossum immunity, hoping to develop treatments for snakebite in humans. The opossum's diet is omnivorous and opportunistic, the animal eating almost anything including fruits, insects, small animals, and carrion. This flexibility making opossums successful survivors who thrive in varied habitats. The animals providing ecosystem services by consuming ticks, carrion, and other potentially harmful organisms. The opossum shuffles through the night with its long, naked tail, acting as a balance and prehensile grasping tool. The tail being able to wrap around branches to steady the opossum while climbing, the animal being ungainly in appearance, but successful in practice. A living fossil that has persisted for millions of years essentially unchanged, the opossum being a survivor that minds its own business and makes do with whatever it finds. The flying squirrel does not actually fly but rather glides through the forest canopy, launching from high perches and sailing on outstretched membranes that stretch between its front and hind legs. This gliding ability allowing the squirrel to travel efficiently through three-dimensional forest space without descending to the dangerous forest floor. The gliding membrane, called a patagium, is furred skin that folds against the body when not in use, becoming almost invisible when the squirrel is at rest, but spreading into a rectangular lifting surface when the squirrel extends its limbs during a glide. The tail serves as a rudder during glides, the squirrel adjusting tail position to steer and to control pitch. The tail also being flattened to provide additional surface area, the squirrel having remarkable control over its glide path, despite having no propulsive power. The squirrel can glide over 300 feet in a single jump, though typical glides are much shorter, the squirrel selecting landing sites and gliding directly to them with accuracy that allows landing precisely on chosen branches. Just before landing, the squirrel swings its body upright and spreads its tail wide, this action increasing drag dramatically and slowing the squirrel enough that the landing is gentle, the squirrel grabbing the landing branch with its sharp claws and immediately scurrying to the opposite side to avoid aerial predators that might be following. The flying squirrel's eyes are enormous, being proportionally larger than almost any other rodent's eyes. These oversized eyes gathering maximum available light to support vision in darkness, the eyes being so large that they make the squirrel's appearance cartoonish, the animal looking perpetually surprised or alert. The squirrels communicate through ultrasonic vocalizations that are largely inaudible to humans, these high-frequency sounds serving to maintain spacing in the forest and to coordinate social interactions, the ultrasonic calls being above the hearing range of many predators, allowing the squirrels to communicate without alerting the owls that hunt them. The eye is perhaps the strangest primate. This lemur possessing enormous eyes adapted for night vision, bat-like ears that rotate independently to detect sounds, and an extremely elongated middle finger that it uses to extract insects from tree bark, in a hunting method found in no other primate. The eye taps on tree bark with its long middle finger, listening with its sensitive ears to the hollow sounds that indicate insect galleries beneath the surface. This percussive foraging being similar to the method woodpeckers use, though the eye is finding prey through sound rather than through the vibrations that woodpeckers detect. Once the eye locates an insect tunnel, it gnaws through the bark with its rodent-like continuously growing incisors. These teeth being unusual for a primate but being perfect for creating small holes in wood, then the elongated middle finger is inserted into the hole, the finger having a ball and socket joint that allows extreme flexibility, the eye using the finger to hook insects from their galleries and pull them out. The eye's appearance has made it the subject of superstitions in Madagascar. Many local people considering the animal to be an omen of bad luck, this folklore has contributed to eye persecution and making conservation more challenging. The eye lives alone, occupying a territory that it defends from other eyes, the animals meeting only to mate, spending their nights in solitary foraging through the forest canopy. The eye builds elaborate spherical nests woven from leaves and branches high in trees, these nests providing shelter during daylight hours when the eye sleeps, each individual maintaining several nests within its territory and rotating between them, rather than using a single permanent den. The eye represents the creative power of evolution, taking the basic primate body plan and modifying it in unexpected ways to fill an ecological niche, the animal being proof that evolution produces solutions tailored to specific circumstances rather than following predictable patterns. The eye being weird, but being weird for good reasons. Its strangeness being perfect adaptation to a particular way of life. The kiwi bird is flightless and nocturnal, hunting by smell rather than sight. This strategy being unusual among birds, which typically rely heavily on vision, the kiwi having nostrils at the tip of its long beak rather than at the base, like most birds, allowing the bird to sniff the ground as it probes for food. The kiwi's sense of smell rivals that of mammals, the olfactory bulb being large relative to brain size, the bird being able to detect earthworms and insect larvae hidden beneath the soil surface, the long beak being inserted into the ground until prey is found. The bird then extracting the food item and swallowing it whole. The kiwi's feathers are unusual, being hair-like rather than having the structured form typical of bird feathers, these modified feathers providing insulation but not being suitable for flight, the kiwi's wings being so reduced that they are barely visible, the bird being entirely terrestrial and running on powerful legs rather than flying. The kiwi's egg is enormous relative to the bird's body size, weighing about 20% of the female's body weight, this being equivalent to a human woman giving birth to a toddler. The female kiwi showing remarkable dedication by producing such an enormous egg, though she leaves most of the incubation duties to the male who sits on the egg for over 2 months. The kiwi is the national symbol of New Zealand, the birds being endemic to those islands, and being found nowhere else, though kiwi populations have declined due to introduced predators including rats, cats, and stoats that prey on kiwi eggs and chicks. Conservation programs now focusing on predator control and captive breeding to prevent extinction. The kiwi shuffles through the nighttime forest floor, its long beak probing constantly, the bird being patient and thorough, investigating every promising location, the kiwi being more mammal than bird in its habits, filling a role that mammals occupy in other ecosystems, the bird proving that body plans are less important than adaptation, that success comes not from flying or running or swimming, but from finding a way of life and perfecting it. The red fox hunts primarily at night, using a combination of excellent hearing, keen eyesight, and a sensitive nose to locate prey in darkness. The fox's hunting technique, often involving a characteristic pouncing leap, where the fox jumps high into the air and comes down on prey, with its front paws pinning the target to the ground. The fox can hear a mouse squeaking from over 100 feet away, this acute hearing being essential for detecting small mammals moving beneath snow or vegetation. The fox tilting its head to pinpoint the sound's location before launching its attack. The fox's vertical leap can reach 6 feet in height. This impressive jump, allowing the fox to clear obstacles and to come down on prey with sufficient force to stun or kill through impact. The hunting technique being energy efficient because successful strikes require less effort than prolonged chases. The fox adapts its hunting strategy to available prey, switching between pouncing for rodents, stalking for rabbits, and opportunistic scavenging when live prey is scarce. This flexibility, making foxes successful in environments ranging from wild forests to urban neighborhoods. The fox's bushy tail serves multiple functions beyond balance, providing warmth when wrapped around the body during cold weather, serving as a signal flag during social encounters with other foxes, and possibly acting as a distraction to prey or predators. The tail being nearly as long as the body, and making the fox appear larger than it actually is. The fox's coat changes with seasons, becoming thicker and softer in winter, then shedding to a thinner summer coat. This adaptation, allowing the fox to maintain comfortable body temperature across seasons without requiring shelter beyond a simple den. The fox trots through the night with confident grace, the animal being equally comfortable in wilderness and suburb, adapting to human presence while maintaining its wild nature, the fox being a survivor that thrives through intelligence and flexibility. The russet coat and white-tipped tail being glimpses of wilderness that persist even in cities, reminders that wild things continue their ancient patterns despite human transformation of landscapes. The pangolin is the world's most trafficked mammal. These scale-covered creatures being hunted for their scales and meat, despite being protected by international law, the pangolin's defense of rolling into an armored ball, being effective against natural predators, but making it easy for humans to collect the defenseless animals. The pangolin's body is covered with overlapping scales made of keratin, the same material as human fingernails. These scales being hard and sharp-edged, providing protection from biting and clawing predators, the scales covering everything except the belly and face, which remain vulnerable when the pangolin rolls into its defensive ball. The pangolin has no teeth, instead possessing an extraordinarily long tongue that can extend over 16 inches from the mouth, this tongue being covered with sticky saliva and being used to lap up ants and termites from their nests, the pangolin consuming thousands of insects in a single night's feeding. The pangolin's stomach contains small stones and keratinous spines that grind the insects after they are swallowed. This gizzard-like grinding chamber, compensating for the lack of teeth, breaking down the tough exoskeletons of ants and termites to release nutrients. The pangolin walks on its hind legs while using its front claws and tail for balance, this unusual bipedal gait making the animal look almost prehistoric, the powerful front claws being designed for tearing apart termite mounds and ant nests rather than for walking. The pangolin is solitary and nocturnal, spending days sleeping in burrows and emerging after dark to forage. The animal walking slowly through forests and savannas, while its sensitive nose searches for insect colonies, the pangolin being patient and methodical in its nightly rounds. The pangolin mother carries her infant on her tail, the young pangolin riding along during foraging trips and learning to find food by observing the mother. This maternal care lasting for several months, until the young pangolin becomes independent. The pangolin curls into its armored ball, protected from almost everything except human greed, the animal being a victim of its own defenses, which make capture easy. The pangolin representing countless species whose survival depends not on their own adaptations, but on human choices about protection and preservation. The tarsier possesses the largest eyes relative to body size of any mammal, each eye being larger than the animal's brain. These enormous eyes gathering maximum light for vision in darkness, the eyes being so large that they cannot rotate in their sockets, requiring the tarsier to turn its head to look in different directions. The tarsier can rotate its head nearly 180 degrees in each direction, this extreme neck flexibility compensating for the fixed eyes, allowing the tarsier to look directly backward without moving its body. This owl-like head rotation being unusual for a primate, but being necessary given the eye structure. The tarsier's eyes provide excellent depth perception through binocular vision, the forward-facing eyes creating overlapping visual fields that allow precise distance judgment, this being essential for the tarsier's hunting method, which involves leaping from branch to branch while pursuing flying insects. The tarsier is the only completely carnivorous primate, eating exclusively insects and small vertebrates, the animal being an active predator rather than a fruit or leaf eater like most primates, this dietary specialization requiring the tarsier to be an efficient hunter. The tarsier's hind legs are extremely long relative to its body, these elongated limbs storing elastic energy and allowing leaps of over 40 times the animal's body length, this jumping ability being remarkable and allowing the tarsier to travel through forest canopy without descending to the ground. The tarsier hunts by waiting motionlessly on a perch, its enormous eyes scanning for movement, then launching itself toward prey in a single explosive leap, the hands grabbing insects from the air or from surfaces, the hunting being more similar to a frog catching flies than to typical primate foraging. The tarsier's fingers and toes bear adhesive pads that allow grip on smooth surfaces, these pads functioning like suction cups and allowing the tarsier to cling to vertical tree trunks and branches, providing security while perching and hunting. The tarsier lives in Southeast Asian forests, being active only at night, the huge eyes gleaming when caught in flashlight beams, the animal being shy and difficult to observe, living its life in the forest canopy, where few humans venture. The tarsier being proof that primates are more diverse than commonly imagined, that not all of our relatives are social, diurnal, and omnivorous. The badger emerges from its set at dusk, this extensive burrow system being home to family groups that may have occupied and expanded the same tunnel network for generations. Some badger sets being centuries old and containing dozens of entrances and hundreds of feet of interconnected passages. The badger's powerful front legs and long claws are perfectly designed for digging, the badger being able to excavate new tunnels rapidly and to enlarge existing chambers when needed, the set being constantly maintained and modified to serve the clan's needs. The badger is primarily nocturnal, spending daylight hours underground and emerging only after sunset to forage through its territory. The animal following habitual paths night after night, wearing visible trails through vegetation as it travels between the set and favorite feeding areas. The badger's diet is omnivorous, but emphasizes earthworms, a single badger consuming hundreds of worms per night when conditions are suitable, the badger using its sensitive nose to detect worms near the soil surface, then digging them out and consuming them immediately. The badger marks its territory through latrines, small pits dug specifically for defecation, these communal toilets serving as boundary markers that communicate the clan's presence to neighboring badger groups, the latrines being maintained year after year, and being one of the most reliable signs of badger activity. The badger's distinctive black and white facial stripes may serve as warning coloration, advertising the badger's defensive capabilities, these markings being visible even in low light, and potentially signaling to predators that the badger is formidable and not worth attacking. The badger's loose skin and thick fur provide protection from bites and scratches, predators finding it difficult to inflict serious wounds on an animal that can twist within its own skin. The badger being tough and tenacious, rarely backing down from confrontations despite not being particularly aggressive. The badger shuffles through the night, following ancient paths. The animal, being a creature of habit, reliable as seasons, the badger's persistence across centuries, being testament to a successful life strategy. The animal asking nothing but to be left alone, to dig its tunnels and find its worms. The badger being neither beautiful nor dramatic, but being thoroughly successful at being a badger. The slow loris moves through the canopy with deliberate grace, the animal never hurrying, each movement being careful and controlled. This slow movement being both energy efficient and providing camouflage by making the loris difficult for predators to detect against moving foliage. The slow loris possesses a toxic bite, being the only venomous primate. The toxin being produced in glands on the elbows, the loris licking these glands before biting, mixing the venom with saliva to deliver it through its teeth. This toxic bite causing painful swelling and in rare cases triggering severe allergic reactions in humans. The venom likely evolved as defense against predators rather than for capturing prey, the loris using its venomous bite primarily when threatened, though mothers also lick their young to coat them with toxin before leaving to forage, this chemical protection potentially deterring predators during the mother's absence. The slow loris's enormous eyes gather light efficiently, providing vision in darkness, though the animal also relies heavily on smell, marking its territory with urine, and possessing scent glands that communicate information to other lorises about identity, reproductive status, and territory ownership. The slow loris grips branches with a strong grasp, the hands and feet having opposable thumbs and modified blood vessels that allow sustained gripping without muscle fatigue. The loris being able to hang motionless for hours while waiting for prey or hiding from predators. The slow loris captures insects by stalking within range, then suddenly grabbing them with both hands. This ambush strategy being more successful than chasing mobile prey through branches, the loris's apparent sluggishness being deceiving because the final strike is surprisingly fast. The slow loris is threatened by the illegal pet trade, the cute appearance, and slow movements, making lorises appealing to people who want exotic pets. Though the animals require specialized care and suffer greatly in captivity, many dying shortly after capture, the pet trade driving population declines across the loris's range. The slow loris inches along branches, moving through the night like a furry sloth, the animal being patient beyond measure, embodying the truth that speed is not essential for survival, that careful, methodical movement succeeds, as well as hurried rushing. The loris, demonstrating that slowness can be a strength rather than a weakness. The spotted hyena is primarily nocturnal, hunting and scavenging under cover of darkness, the animal possessing excellent night vision and acute hearing that allow it to locate food sources that diurnal predators miss. The hyena being equally successful at killing prey and at scavenging from the kills of other predators. The hyena's jaw muscles are extraordinarily powerful, generating bite forces that exceed those of big cats, allowing the hyena to crush bones that other carnivores leave behind, the hyena extracting nutrition from carcass parts that would otherwise be wasted. This bone-crushing ability being enabled by massive jaw muscles and specially strengthened skull architecture. The hyena's digestive system can process bone fragments, hide, and other tough materials, extracting nutrients that would pass through other carnivores undigested. This digestive efficiency allowing hyenas to utilize carcasses more completely than any other large African predator, the hyenas being cleanup crew that recycles nutrients back into the ecosystem. The hyena lives in complex social groups called clans, these societies being led by females who are larger and more aggressive than males, the social hierarchy being strictly enforced through ritualized behaviors and occasional fights. Cubs inheriting their mother's social rank. The hyena's famous laugh is actually a vocalization, indicating frustration or excitement, being just one of many sounds in the hyena's repertoire that includes whoops that carry for miles across the savanna, allowing clan members to communicate across large distances and to coordinate group activities, including hunts and territorial defense. The hyena is actually an effective hunter, killing more prey than it scavenges. Despite the popular image of hyenas as cowardly scavengers, group hunts being coordinated and successful, hyenas regularly bringing down prey as large as wildebeest through teamwork and persistence. The hyena clan territories are marked with paste from anal glands, this secretion creating a chemical signature that identifies the clan. The paste being deposited on grass stalks throughout the territory, creating a scent boundary that neighboring clans generally respect. The hyena trots through the night, ears forward and nose testing the wind. The animal being intelligent and social, the clan being a cooperative that shares resources and raises young communally, the hyena being far more sophisticated than its reputation suggests. The whooping laughter echoing across darkness, being the sound of successful survivors who have thrived in Africa for millions of years. The nightjar sits motionless on the ground during the day, its mottled brown plumage providing perfect camouflage against leaf litter, the bird being nearly invisible even when a person walks within feet of its resting place. This cryptic coloration being so effective that nightjars are rarely seen despite being fairly common. The nightjar's mouth is enormous relative to its head size, this huge gape allowing the bird to catch flying insects. While in flight, the bird flying with mouth open through swarms of moths and beetles, scooping insects from the air like a living net. The nightjar's mouth is surrounded by bristles, these modified feathers possibly serving as tactile sensors that detect insects entering the mouth, or perhaps acting as a funnel that guides insects toward the throat, or possibly protecting the eyes from struggles of captured insects. The exact function remaining debated among researchers. The nightjar hunts on the wing during twilight hours, flying with buoyant, erratic flight that resembles a large moth, this aerial hawking being highly successful when insects are abundant. The nightjar catching enough food in an hour or two of intensive feeding to sustain it for the entire day. The nightjar's eyes contain a reflective tapetum lucidum, creating bright eyeshine when lights illuminate the bird at night. This reflective layer enhancing light-gathering efficiency and allowing the nightjar to detect flying insects in very low light levels, when visual hunting would otherwise be impossible. The nightjar produces strange churring calls that continue for minutes without pause, these mechanical-sounding vocalizations being territorial signals and mate attraction calls, the churring being so continuous that it seems impossible the bird maintains it without breathing, though careful observation reveals brief pauses for breath. The nightjar nests directly on the ground, laying eggs in a simple scrape without constructing any nest structure, the eggs being cryptically colored and the incubating adult remaining motionless, relying entirely on camouflage rather than on defended nest site. This minimal nesting being possible because the bird feeds efficiently enough that it needs little time away from eggs. The nightjar is a ghost of twilight, appearing from nowhere when dusk falls, flying silently through the gloom on soft wings, catching invisible prey, then vanishing before dawn, the bird being present but rarely seen, heard but mysterious. The churring sound being one of summer's characteristic night sounds, despite few people knowing what creature produces it. The sugar glider glides between eucalyptus trees in Australian forests, this small marsupial spreading its gliding membrane and sailing through darkness with remarkable control, the membrane stretching from wrists to ankles and allowing glides of over 150 feet. The sugar glider's large eyes provide good night vision, though the animal also navigates using scent marks. It deposits throughout its territory these chemical signals, providing information about paths between trees and alerting the glider to the presence of other gliders. The sugar glider lives in family groups containing a dominant male, several females, and their offspring. These social units sharing a nest hollow and foraging together, the group members grooming each other and sleeping in communal piles that conserve heat during cold nights. The sugar glider feeds primarily on plant sap and nectar, using its sharp teeth to create holes in bark, then licking the exuding sap. This feeding behavior making sugar gliders important pollinators for some eucalyptus species that flower at night. The sugar glider's tail serves as a rudder during glides, the animal adjusting tail position to steer and control pitch, though the tail is not prehensile and cannot grip branches like some other marsupial tails do. The sugar glider communicates through various vocalizations, including loud barking calls that carry through the forest. These calls serving to maintain group cohesion and to advertise territory ownership, warning other glider groups to keep their distance. The sugar glider's gliding appears effortless, the small animal launching confidently from high perches, spreading its membrane, and sailing gracefully to landing sites, then immediately scurrying to the far side of the trunk to avoid aerial predators. The glider being vulnerable during the final moments before landing when its trajectory is fixed. The sugar glider represents the convergent evolution of gliding. This ability having evolved independently in multiple marsupial lineages, and also in rodents and lemurs, the gliding lifestyle being successful enough that evolution discovers it repeatedly. The sugar glider, proving that flight is not the only way to travel through three-dimensional forest space. The leopard is primarily nocturnal, hunting under cover of darkness when its spotted coat provides camouflage in the dappled shadows beneath trees. The leopard being perhaps the most adaptable big cat, living successfully in environments ranging from rainforests to semi-deserts, from mountains to river margins. The leopard hunts by stealth, stalking to within pouncing distance, then rushing prey with explosive acceleration, the attack being over in seconds. The leopard using surprise rather than prolonged chase. This ambush strategy being energy efficient and having high success rates when properly executed. The leopard's strength is remarkable relative to its size, the cat being capable of carrying prey heavier than itself up into trees. This hoisting behavior, protecting kills from scavengers like hyenas that would otherwise steal the leopard's food. The leopard caching carcasses in trees and returning over several days to feed. The leopard is solitary, except during mating and while females raise cubs, each adult maintaining a territory marked with scent posts, scratch marks, and vocalizations that warn other leopards to keep out, though territories may overlap, and leopards sometimes tolerate neighbors passing through their ranges. The leopard spots, called rosettes, are unique to each individual. These complex patterns providing both camouflage and identification, researchers using spot patterns to recognize individual leopards in camera trap photos, creating catalogs of local populations without needing to capture the animals. The leopard adapts its diet to locally available prey, eating everything from insects to young buffalo. This flexibility allowing leopards to persist in areas where more specialized predators struggle, the leopard being equally successful hunting monkeys in trees, fish in shallow water, or antelope on the ground. The leopard is increasingly threatened by habitat loss and conflict with humans. The cats sometimes preying on livestock when wild prey becomes scarce, leading to retaliatory killing by farmers and herders. Conservation requiring programs that compensate for livestock losses and that provide leopards with wild prey populations. The leopard ghost walks through the night, spotted coat blending with shadows. The cat being powerful but cautious, avoiding confrontation when possible, using intelligence and adaptability to survive in a changing world. The leopard's presence, indicating healthy ecosystems where predators still have space to hunt. The kakapo is the world's only flightless parrot, this large nocturnal bird being endemic to New Zealand, where the lack of mammalian predators allowed a ground-dwelling lifestyle to evolve, though introduced predators brought by humans nearly drove the kakapo to extinction. The kakapo weighs up to 9 pounds, being the heaviest parrot. This body mass being far too great for flight, given the wing size. The kakapo, using its wings only for balance, while climbing trees, or to slow its descent when jumping from branches. The kakapo's plumage is green and yellow with cryptic patterns, providing excellent camouflage in the forest understory. The bird's strategy when threatened being to freeze motionlessly, relying on camouflage rather than flight. This defense being effective against native raptors, but useless against mammals that hunt by scent. The kakapo is herbivorous, feeding on plants, fruits, and seeds. The bird having a specialized digestive system that can process tough native vegetation, the grinding gizzard, and long intestines, extracting maximum nutrition from fibrous plant material. The kakapo's breeding system is unusual. Males gathering at traditional display grounds where they excavate bowl-shaped depressions in the ground, then spending nights producing deep booming calls that carry for miles through the forest, advertising their presence to females. The male's boom can be heard from over a mile away. This low-frequency sound, traveling well through forest and being produced by inflating an air sac on the chest, the booming continuing through the night for months during breeding season, each male attempting to attract females to his display court. The kakapo females visit booming males, mate, then raise chicks entirely alone without male assistance, the eggs and chicks being vulnerable to predators, but being protected somewhat by the female's vigilance and by the remote locations where nests are built. The kakapo population fell to fewer than 50 individuals before intensive conservation efforts began rescuing the species. All surviving kakapos being known individually, the birds living on predator-free islands, where their every movement is monitored, breeding being managed to maximize genetic diversity. The kakapo representing a conservation success story still in progress, the species surviving only through human intervention. Every chick hatched being celebrated as a victory. The fennec fox is the smallest fox species, inhabiting North African deserts where its nocturnal habits allow avoidance of the extreme daytime heat. The fox, sleeping in underground burrows during the day and emerging only after sunset, when temperatures become tolerable. The fennec fox's enormous ears serve multiple functions, radiating body heat to help cool the animal, the large surface area and blood vessels near the skin, releasing excess heat into the night air. This cooling being essential in an environment where overheating is a constant danger. The enormous ears also provide exceptional hearing, allowing the fennec fox to detect insects, rodents, and lizards moving beneath sand. The fox cocking its head to pinpoint prey location, then digging rapidly to capture the animal. This hunting method being similar to kit foxes in North American deserts. The fennec fox's feet are heavily furred, including the pads, this fur providing insulation from hot sand during evening hours when the surface retains daytime heat. The furry feet also providing traction on loose sand, functioning like snowshoes that distribute the fox's weight and prevent sinking. The fennec fox lives in family groups, multiple individuals sharing burrow systems and raising young cooperatively, this social structure being unusual among foxes, and perhaps being an adaptation to harsh desert conditions, where cooperation improves survival. The fennec fox's light-colored coat reflects sunlight and provides camouflage against sandy backgrounds. The cream-colored fur, keeping the fox cool through albedo effect, while also making the animal difficult to spot against desert sand and rock. The fennec fox obtains most of its water from food, the animal being adapted to survive with minimal drinking water. The kidneys being highly efficient at concentrating urine and conserving water. This adaptation, allowing survival in areas where free water may be unavailable for long periods. The fennec fox trots through the cooling desert night, the enormous ears rotating independently to catch sounds. The fox being alert and opportunistic, eating insects, plants, small vertebrates, and whatever else it encounters. The animal succeeding through adaptability and through physical adaptations that allow comfort in one of Earth's harshest environments. The Australian ghost bat is one of the largest microchiropteran bats, hunting vertebrate prey, including other bats, rodents, birds, and large insects. This carnivorous diet being unusual among smaller bat species that typically specialize on insects. The ghost bat's hunting technique involves hanging in wait at cave entrances or in vegetation, watching for prey to approach, then dropping onto the victim and wrapping it in the wing membranes before delivering a killing bite. This ambush strategy being effective for capturing prey too large to catch in aerial pursuit. The ghost bat's ears are enormous and highly mobile, providing acute hearing that allows detection of prey movement at considerable distances. The bat using passive listening as well as echolocation, often hunting without echolocating when listening alone, provides sufficient information. The ghost bat roosts in colonies in caves and abandoned mines, hanging individually rather than clustering tightly like many bat species. The spacing, perhaps reducing parasite transmission, or perhaps reflecting the species' more aggressive temperament. The ghost bat's name derives from its pale coloration, the whitish-gray fur making the bat appear spectral when caught in light. This coloration being unusual among bats which tend toward brown and black, the adaptive significance of the pale coloration remaining unclear. The ghost bat female typically gives birth to a single young rather than twins. This low reproductive rate being compensated by parental care that extends for several months, the young bat flying with the mother on foraging trips before becoming fully independent. The ghost bat population has declined due to disturbance of roost sites, the bats being sensitive to human intrusion and abandoning caves that receive regular visitation, conservation requiring protection of key roost sites, and limiting access during breeding season. The ghost bat is an apex predator among bats, this role being unusual for a species that is itself prey for larger raptors and snakes. The bat being both hunter and hunted, occupying a middle position in desert food webs, the armadillo forages through the night, using its excellent sense of smell to detect insects, grubs, and other invertebrates buried in soil. The armadillo's long pointed snout being perfect for probing ground and leaf litter while sniffing for food. The armadillo's armor consists of bands of hardened dermal plates covered by horn-like skin, providing protection from thorns, biting ants, and predators, though contrary to popular belief, most armadillo species cannot roll into a complete ball. Only the three-banded armadillo having this ability. The armadillo digs extensively, excavating burrows for shelter and creating numerous holes while foraging for insects. A single armadillo may dig several burrows within its territory and maintain multiple escape dens throughout its home range. The armadillo's digging ability is remarkable, the powerful front claws excavating rapidly in even hard-packed soil, the armadillo sometimes completely disappearing into the ground within minutes when digging, this burrowing ability providing escape from predators and access to underground prey. The armadillo can hold its breath for several minutes, allowing it to continue digging with its nose buried in loose soil. And the ability to inflate its intestines allows the armadillo to float when crossing water bodies, this unlikely swimming adaptation, enabling armadillos to colonize new areas by swimming across rivers. The armadillo's body temperature is lower than most mammals, and the metabolic rate is also low. These factors making armadillos vulnerable to cold, the animals being restricted to areas where winter temperatures rarely drop below freezing. The armadillo gives birth to identical quadruplets, all four offspring developing from a single fertilized egg. This unusual reproductive pattern being consistent across all 9-banded armadillo pregnancies, the quadruplets being genetically identical and always being the same sex. The armadillo shuffles through darkness, nosing through leaf litter, the small creature being unconcerned with appearance, the armor being functional rather than decorative, the armadillo succeeding through simple effectiveness, the animal finding food efficiently and reproducing successfully, asking nothing more from life than insects to eat and soft soil in which to dig. The potu bird roosts motionlessly during the day, perched upright on a broken branch or stump. The bird's cryptic plumage and posture, making it appear to be part of the dead wood itself. This camouflage being so effective that people can stand beneath a roosting potu without noticing the bird, despite it being in plain view. The potu's eyes are large and adapted for night vision, though during daytime, roosting the bird keeps its eyes nearly closed, leaving only narrow slits that allow the bird to watch for danger while maintaining its wooden appearance. the eye slits being positioned so that the potu can monitor its surroundings without moving its head. The potu hunts from a perch, sitting motionlessly while watching for flying insects, then launching brief sallies to snatch prey from the air before returning to the same perch. This sit-and-wait strategy being energy efficient and allowing the potu to hunt successfully through the night without covering large distances. The potu's mouth is enormous, perhaps the largest gape relative to body size of any bird. This huge mouth allowing the bird to catch large moths and beetles. The potu simply flying with mouth open through the flight path of prey, the insect being engulfed before it can react. The potu produces mournful calls that carry through tropical forests at night, these calls sounding eerily human-like, leading to folklore and superstitions in many regions where potus live, the calls being part of territorial behavior and mate attraction. The potu lays a single egg directly on top of a broken branch or in a small depression, without constructing any nest. The egg and later the chick, relying entirely on camouflage for protection. The incubating adult, looking exactly like a continuation of the branch. This minimal nesting strategy working because of the potu's exceptional camouflage. The potu sits through the night, silent and still except for brief hunting flights. The bird, being a master of patience, embodying the art of doing nothing. The potu proving that successful predation doesn't require constant activity, that waiting and watching succeed as well as energetic searching. The potu being perfectly content to sit and wait for food to fly past. The serval is a medium-sized African wildcat with extraordinarily long legs and large ears. These adaptations being specialized for hunting rodents in tall grasslands, where the serval must hear prey moving through dense vegetation and must pounce accurately, despite not being able to see the prey directly. The serval's hunting technique involves walking slowly through grassland while listening for prey. The huge ears rotating independently to pinpoint sound sources, then executing remarkable vertical leaps that carry the serval 6 feet or more into the air, the cat coming down on prey with front paws extended. The serval's success rate is among the highest of any cat, nearly 50% of hunts resulting in captures. This efficiency coming from the serval's patience in approaching the final leap, and from the accuracy provided by excellent hearing and kinesthetic sense that allows precise pouncing on hidden prey. The serval's spotted coat provides camouflage in dappled grassland shade, though the spots may also function as disruptive coloration that breaks up the cat's outline when moving through vegetation, making it difficult for prey to recognize the approaching predator. The serval is primarily nocturnal and crepuscular, being most active during dawn and dusk, when its prey is also active. Though in areas without human disturbance, servals sometimes hunt during daytime, particularly on overcast days, when their prey remains active. The serval's long legs allow it to see over tall grass when standing, providing a height advantage for detecting prey and for watching for dangers, including larger predators that might threaten the serval, this elevated viewpoint being valuable in the serval's grassland habitat. The serval occasionally catches birds, leaping vertically to snatch flying birds from the air, this hunting being opportunistic rather than the main feeding strategy, though it demonstrates the serval's remarkable jumping ability and aerial agility. The serval patrols its territory, marking boundaries with scent and vocalizations, the territories being maintained year-round and defended against other servals, though males and females tolerating each other briefly during mating season. The serval bounds through grassland, ears scanning constantly, the cat being focused and efficient, the serval representing specialization for a particular hunting method, the long legs and large ears being extreme adaptations that work perfectly in the serval's chosen environment. The kinkajou lives in Central and South American rainforests, this relative of raccoons being entirely arboreal and nocturnal, spending its life in the canopy, where it moves through branches with remarkable agility, aided by its prehensile tail. The kinkajou's tail functions as a fifth limb, able to grip branches securely and support the animal's full weight, allowing the kinkajou to hang while feeding, or to anchor itself while reaching for fruit at branch tips. this tail being unique among carnivorous mammals of the Americas. The kinkajou feeds primarily on fruit, particularly figs, though it also consumes nectar, flowers, and occasional insects or small vertebrates, the animal's broad diet, allowing it to find food year-round despite seasonal changes in fruit availability. The kinkajou has an extremely long tongue, this organ extending up to 5 inches beyond the mouth, and being used to extract nectar from tubular flowers and to retrieve insects from crevices, the tongue providing access to food resources that other canopy animals cannot exploit. The kinkajou's role as a pollinator is significant. The animal visiting flowers to drink nectar and becoming covered with pollen that is transferred to subsequent flowers, making kinkajous important for reproduction of various rainforest trees that bloom at night. The kinkajou makes various vocalizations, including barks, screams, and a whistling call. These sounds serving to maintain contact between individuals and to advertise territory. The calls carrying through the nighttime forest and allowing kinkajous to monitor each other's locations without visual contact. The kinkajou's eyes reflect light with a bright orange eye shine. This reflection being created by the tapetum lucidum that enhances night vision, the eye shine, making kinkajous relatively easy to spot with flashlights, despite the dense canopy and the animal's nocturnal habits. The kinkajou's hands and feet can rotate backward, allowing the animal to run down tree trunks head first, this ability being useful for descending to lower canopy levels and for escaping predators by rapidly moving to safer positions. The kinkajou swings through darkness, tail gripping, hands reaching, the animal being as comfortable upside down as right side up. The kinkajou, living a life of three-dimensional movement through space, filled with branches, never touching ground, the canopy being complete world where everything needed exists at height. The aardvark is the sole remaining member of an ancient mammalian order. This peculiar African animal being specialized for eating ants and termites, the aardvark emerging from its burrow after sunset to search for insect colonies, using its excellent sense of smell. The aardvark's snout is long and pig-like, though the animal is not related to pigs, the snout being extremely sensitive to smell and being used to detect underground termite galleries, the aardvark pausing frequently while foraging to sniff the ground for signs of insects beneath. The aardvark's digging ability is extraordinary. The powerful front claws excavating termite mounds and ant nests with remarkable speed, the aardvark, sometimes completely demolishing large termite mounds in a single night's feeding, the strong claws and muscular shoulders providing the power for this intensive excavation. The aardvark's tongue is long and sticky, extending over a foot from the mouth and being covered with adhesive saliva that traps ants and termites. The tongue lapping up thousands of insects per night, the aardvark consuming up to 50,000 termites in a single feeding session. The aardvark's ears are long and tubular, able to fold flat against the head during digging to prevent soil from entering the ear canals. This protective adaptation being necessary, given the aardvark's tendency to bury its head completely while excavating, the ears popping back up when the aardvark surfaces. The aardvark excavates extensive burrow systems, these underground refuges providing shelter during daytime, and being complex enough to include multiple entrances and chambers, the burrows being important not just for the aardvark, but also for numerous other species that use abandoned aardvark burrows for shelter. The aardvark's teeth are unique among mammals, lacking enamel and consisting of dentine tubes clustered together. These teeth growing continuously throughout life and being suitable for grinding but not for biting, the teeth being adequate for the aardvark's soft diet of insects. The aardvark walks through the night, snout to ground, ears swiveling, the strange creature being perfectly designed for its unusual lifestyle, the aardvark proving that evolution produces specialists alongside generalists, that there are many ways to make a living, the aardvark's success lying in its singular focus on a food source that few other large mammals can exploit. The fishing cat is a medium-sized wildcat that specializes in catching fish and aquatic prey. Being an excellent swimmer and having partially webbed paws that provide propulsion in water, this aquatic adaptation being unusual among cats which typically avoid water. The fishing cat hunts along rivers, streams, and wetlands, sitting at the water's edge and watching for fish, then scooping them from the water with its paw in a rapid strike that impales the fish on the claws. This fishing technique being precise and efficient. The fishing cat can dive underwater to pursue fish, the cat being comfortable swimming completely submerged and being able to remain underwater for brief periods while hunting, this diving ability being unique among small wildcats and demonstrating the species' commitment to aquatic hunting. The fishing cat's coat is water-resistant, the outer layer of fur repelling water and allowing the cat to shake itself relatively dry after swimming. This adaptation being important because wet fur loses insulating properties and would cause dangerous heat loss if the cat couldn't dry quickly. The fishing cat is primarily nocturnal and crepuscular, hunting during times when fish are near the surface and when the cat's vision provides advantages over prey, the dim light conditions making fish less able to detect the cat's approach. The fishing cat's claws are only partially retractile, protruding slightly even when relaxed. These semi-retracted claws providing better grip on slippery fish and on muddy riverbanks, though making the cat's footsteps more audible on hard surfaces. The fishing cat is threatened by wetland destruction, the draining and development of marshes and mangroves reducing available habitat, making fishing cat populations increasingly isolated and vulnerable, conservation requiring protection of wetland ecosystems that provide habitat for the cat and for countless other species. The fishing cat crouches at the water's edge, still as stone, watching the dark water for movement, then exploding into action when prey approaches. The cat being patient, hunter and explosive striker, the fishing cat proving that cats are more diverse than house cats, suggest that the cat family has members adapted to nearly every habitat and hunting method. The eye taps tree bark with its skeletal middle finger, listening for the hollow echoes that indicate insect galleries beneath, this percussive foraging being unique among primates and demonstrating that evolution can produce similar solutions in unrelated groups. The eye having independently evolved a feeding strategy similar to woodpeckers. The eye gnaws through bark with its powerful incisors, creating access holes to insect tunnels. The teeth growing continuously like rodent teeth and being harder than typical primate teeth. These dental adaptations allowing the eye to chew through wood that would damage normal primate teeth. The eye's middle finger is remarkably thin and flexible, able to probe deep into narrow tunnels and to hook larvae from their galleries, the finger having a ball and socket joint that allows rotation in all directions, providing extraordinary dexterity for such a specialized digit. The eye's ears can move independently and provide acute hearing, allowing the animal to detect subtle differences in the sound of tapping on solid wood versus hollow galleries, this acoustic sensitivity being essential for the eye's foraging success. The eye also extracts the soft interior of nuts and fruits by gnawing a small hole, then using its specialized finger to scoop out the contents. This technique, allowing access to food resources that other animals cannot exploit, the eye being able to feed on extremely hard-shelled nuts that resist most other forest animals. The eye's appearance combines features rarely seen together, including bat-like ears, rodent-like teeth, a bushy tail, and enormous eyes. This unusual combination making the eye's appearance unsettling to people unfamiliar with the animal. The strange looks contributing to the superstitions that threaten eye populations in Madagascar. The eye represents the power of evolution to modify the basic mammalian body plan in extreme ways, creating specialists that look barely recognizable as relatives of other primates. The eye being a reminder that evolution is creative and unpredictable, producing solutions that human designers might never imagine, the weird finger being perfect for its purpose, even though it looks like it couldn't possibly work. The striped skunk is perhaps most famous for its defensive spray. But this chemical weapon is a last resort after a sequence of warning behaviors that include foot stamping, tail raising, and even doing handstands to appear larger and more threatening. the skunk preferring to warn rather than to spray. The skunk's spray is produced in anal glands, the fluid being oily and containing sulfur compounds called thiols that have an intensely unpleasant odor, detectable by human noses from over a mile away. This smell being so powerful and long-lasting that predators quickly learn to avoid skunks after a single encounter. The skunk can spray accurately up to 10 feet, aiming the fluid by adjusting the position of the glands and being able to spray multiple times in succession, though the supply is limited and takes days to replenish, making the skunk reluctant to waste spray on minor threats. The skunk's bold black and white coloration serves as warning. This aposematic coloration advertising the skunk's defensive capabilities even in darkness, the pattern being distinctive enough that predators learn to recognize and avoid skunks even before attempting to attack. The skunk is omnivorous and opportunistic, eating insects, small mammals, bird eggs, fruits, and carrion. This dietary flexibility allowing skunks to thrive in varied habitats, including forests, grasslands, and suburban areas. The skunk is largely nocturnal, emerging at dusk to forage through its territory, the animal moving with a distinctive waddling gait, unhurried because few predators dare attack, the skunk being confident in its defenses and therefore being less cautious than animals without chemical protection. The skunk's immune system includes resistance to certain venoms, including that of rattlesnakes. This immunity allowing skunks to prey on venomous snakes occasionally, though such prey is not a dietary staple. The skunk waddles through the night, tail raised like a warning flag, the animal being bold because it can afford to be. The chemical arsenal providing security that speed or camouflage provides to other species. The skunk embodying the principle that the best fight is one avoided, the warning being more effective than the weapon itself. The Tasmanian devil is the world's largest carnivorous marsupial, living only on the island of Tasmania, where it fills the ecological role of apex scavenger, though the devil also hunts prey, including wallabies, possums, and birds, when opportunity allows. The devil's jaw strength is extraordinary relative to its size, producing bite forces that rival those of much larger predators. This crushing power allowing devils to consume entire carcasses including bones, the devil being able to process every part of available carrion except the largest bones. The devil feeds with remarkable efficiency, multiple devils gathering at large carcasses and feeding in noisy, aggressive groups, the competition driving rapid consumption, an entire wallaby carcass being reduced to scattered bones and stains within hours when multiple devils feed. The devil's digestive system can process bone and other tough materials, the animal's droppings appearing white from the calcium content. This complete utilization of carcasses making devils important for nutrient cycling and for removing carrion that might otherwise spread disease. The devil produces loud screeches and growls during feeding, these vocalizations serving to maintain individual space at carcasses and to advertise the devil's presence to other devils, the nighttime feeding sessions being cacophonous affairs that carry through the forest. The devil faces an existential threat from a contagious cancer called devil facial tumor disease. This unusual disease being transmitted through biting during feeding and mating, causing disfiguring tumors that kill affected devils within months. Population declines of over 90% occurring in some areas. Conservation programs are attempting to save the species through insurance populations on disease-free islands and through selective breeding of potentially resistant individuals, though the cancer's rapid spread and high mortality make the devil's future uncertain. The devil is a reminder that diseases can threaten species as much as habitat loss or hunting, that biological threats can emerge unpredictably, the devil's survival, depending on human intervention and on whether resistant devils exist or can be bred. The species representing conservation challenges beyond traditional protection measures. The margay is a small spotted cat living in Central and South American forests, being one of only 3 cat species truly adapted for arboreal life, spending most of its time in trees and possessing remarkable climbing abilities. that surpass those of most other cats. The margay's ankles can rotate 180 degrees, allowing the cat to descend tree trunks head first by reversing its hind feet, this ability being shared with only a few cat species and being essential for the margay's arboreal lifestyle. The margay hunts in trees, pursuing prey including birds, tree frogs, insects, and small mammals through the canopy, the cat being agile enough to catch birds on the wing and to pursue squirrels through the thinnest branches where other predators cannot follow. The margay can hang from branches using only its hind feet, freeing the front paws for grasping prey, this ability allowing hunting techniques impossible for terrestrial cats, the margay being able to reach birds' nests and to capture prey on branch undersides. The margay has been observed mimicking the calls of baby-pied tamarins, apparently using vocal mimicry to lure curious adult tamarins within striking range, this behavior being rare among cats and representing remarkable cognitive sophistication, though more research is needed to understand how widespread this hunting technique might be. The margay's large eyes provide excellent night vision, being proportionally larger than those of most cats, these oversized eyes gathering maximum available light and allowing the margay to hunt in the deep shade of the forest understory, where light levels are extremely low. The margay is threatened by deforestation, the species requiring intact forest and being unable to persist in fragmented or degraded habitats, making the margay an indicator species whose presence signals healthy forest ecosystems. The margay flows through the canopy like liquid, moving along branches with perfect confidence, leaping gaps that would terrify ground-dwelling cats, the margay being as comfortable at height as terrestrial cats are on the ground. The arboreal realm being complete world where the margay finds everything it needs without descending. The binturong is sometimes called the bear cat, though it is neither bear nor cat, but rather a member of the civet family, this tree-dwelling omnivore being native to Southeast Asian forests, where it moves through the canopy with deliberate slowness, using its prehensile tail as an anchor while feeding. The binturong's tail is the only fully prehensile tail found among Asian carnivores. This adaptation, allowing the animal to secure itself while reaching for fruit at branch tips or while sleeping in trees, the tail being strong enough to support the animal's full body weight. The binturong feeds primarily on fruit, particularly figs, though it also consumes leaves, small animals, and carrion. This omnivorous diet allowing the binturong to find food throughout the year despite seasonal changes in fruit production. The binturong smells distinctly of buttered popcorn, this unusual scent being produced by bacteria that colonize the binturong's scent glands, the same chemical compound that gives popcorn its characteristic smell being produced by these microbes, making binturong scent markings unmistakable. The binturong moves slowly through trees, being methodical rather than agile, the animal using its claws and tail to secure itself rather than relying on leaping ability. This cautious movement, reducing the risk of falls, though limiting the binturong's ability to pursue mobile prey. The binturong is primarily nocturnal, though sometimes active during daytime, especially on cloudy days or in areas without human disturbance, the animal being flexible in its activity patterns and adapting to local conditions. The binturong's long, bushy tail and shaggy coat make it appear larger than it actually is. This bulk providing some protection from predators and making the binturong appear more formidable than its temperament suggests, the animal being generally peaceful and avoiding conflict when possible. The binturong climbs through the night, methodical and unhurried, the animal being thorough in its exploration of the canopy, investigating every promising fig tree and every potential food source, the binturong succeeding through persistence rather than speed, the slow approach being adequate when food doesn't run away. The nighthawk is not actually a hawk, but is related to nightjars, hunting flying insects during twilight hours when the bird's erratic flight pattern makes it visible against the sky, the nighthawk catching moths, beetles, and other nocturnal insects in its enormous mouth. The nighthawk's mouth is surrounded by short bristles that may help funnel insects toward the throat, or may protect the bird's eyes from struggling prey. these bristles being particularly well developed in nighthawks that feed on large, hard-bodied beetles. The nighthawk performs spectacular courtship displays, the male diving steeply toward the ground, then pulling up at the last moment, the air rushing through the wing feathers producing a distinctive booming sound. This display being repeated numerous times, while the female watches from a perch. The nighthawk nests on the ground without building any structure, simply laying eggs on bare soil, gravel, or even flat roofs of buildings, the eggs being cryptically colored, and the incubating adult relying entirely on camouflage rather than on nest defense. The nighthawk's cryptic plumage makes roosting birds nearly invisible against bark or leaf litter, the bird sitting lengthwise along branches rather than perching across them like most birds. This unusual roosting posture, enhancing the camouflage by making the bird look like a branch stub. The nighthawk migrates long distances, some populations traveling from Canada to South America, these journeys being accomplished primarily through night flight, when the birds feed while migrating, catching aerial insects to fuel the journey. The nighthawk's population has declined in many areas, possibly due to insect declines from pesticide use, and possibly due to loss of open nesting habitat, as vacant lots and gravel roofs are developed, the nighthawk being one of many species affected by the insect apocalypse that is quietly occurring across much of the world. The nighthawk wheels through twilight, mouth open, scooping insects from the air, the bird being living proof that there are many ways to be a bird, that flight can be erratic and efficient, that beauty lies in function rather than in form alone. The civet produces some of the world's most expensive coffee, the Asian palm civet eating coffee cherries and digesting the fruit pulp while passing the beans intact. Enzymes in the civet's digestive system, altering the bean's chemistry in ways that supposedly improve the coffee's flavor. The civet is not a cat despite the name, being instead related to mongooses and being placed in its own family. These nocturnal omnivores living in forests and plantations across Asia, Africa, and southern Europe, depending on species. The civet's face markings often include masks and stripes, providing camouflage in dappled forest light. Though some species are uniformly colored, the appearance varying considerably across the various civet species. The civet moves with a distinctive low-slung gait, the animal being comfortable both on the ground and in trees, many species being excellent climbers that spend considerable time in the canopy feeding on fruits and hunting for small prey. The civet produces scent secretions from perineal glands, these musky substances being used to mark territory and being so strong-smelling that they were historically collected for use in perfume manufacture, the civet's scent fixing other fragrances and making them longer-lasting. The civet's diet is omnivorous, including fruits, small mammals, birds, reptiles, insects, and carrion. This flexibility, allowing civets to exploit varied food resources and to persist in degraded habitats where specialists struggle. The civet's role as seed disperser is important for forest regeneration, the animals consuming fruits and depositing seeds away from parent trees. The passage through the civet's digestive system, sometimes enhancing germination rates by scarifying tough seed coats. The civet pads through the night, investigating the ground with its nose, climbing trees to reach fruiting branches, the animal being thorough and opportunistic, succeeding through adaptability rather than through spectacular specializations. The civet being quietly successful while more charismatic mammals receive attention. The caracal is a medium-sized cat with distinctive tufted ears, these long black ear tufts being the caracal's most recognizable feature, though their function remains somewhat mysterious, possibly being used for communication through movement, or possibly helping to pinpoint sounds by affecting how sound waves reach the ear. The caracal is an exceptional jumper, able to leap 10 feet straight up from a standing start. This jumping ability being used to catch birds by leaping into flocks taking flight, the caracal sometimes catching multiple birds in a single leap through rapid paw strikes. The caracal's hind legs are proportionally longer than the front legs, giving the cat a distinctive sloping back that provides advantage when leaping, the muscular hind limbs storing elastic energy and releasing it explosively during jumps. The caracal inhabits arid regions across Africa, the Middle East, and India, being adapted to desert and scrubland environments where water may be scarce, the cat obtaining most moisture from prey and being able to survive for extended periods without drinking. The caracal hunts primarily at night, though in areas without human disturbance, the cat is sometimes active during daytime, especially during cooler morning and evening hours, the caracal's activity patterns being flexible and adapting to local conditions. The caracal is solitary except during mating season, each adult maintaining a territory marked with scent posts and scratch marks, these territories being defended against other caracals of the same sex, but sometimes overlapping with territories of the opposite sex. The caracal's populations are declining in some regions due to habitat loss and conflict with farmers who view caracals as threats to livestock, particularly to lambs and young goats, though most caracals prefer wild prey and only occasionally hunt domestic animals. The caracal bounds across the landscape, ears, tufts bobbing, the cat being alert and efficient, the caracal representing the middle ground between small cats and big cats, being large enough to take substantial prey but small enough to be agile and quick, the caracal succeeding through physical abilities rather than through pack hunting or specialized tools. The cuscus is a marsupial related to possums, living in the canopy of New Guinea and northern Australia, moving slowly through trees while feeding on leaves, flowers, and fruits. The cuscus using its prehensile tail as a fifth limb while climbing. The cuscus's tail is partially naked at the tip, the bare section being covered with ridges that provide excellent grip on branches, this bare patch being sensitive to touch and providing tactile information about the branch being grasped. The cuscus's eyes are large and forward-facing, providing good depth perception for judging distances between branches, though the cuscus's movement is so slow and deliberate that it relies more on careful testing than on visual accuracy. The animal moving cautiously through the canopy, the cuscus's fur is often beautifully patterned, with some species showing striking color variations between individuals, the patterns including spots, blotches, or uniform colors ranging from white to black. The function of these patterns being unclear, though they may provide camouflage or individual recognition. The cuscus is entirely arboreal, rarely if ever descending to the ground. The animal finding all necessary resources in the canopy, including food, water from tree hollows and from moisture on leaves, and shelter in tree forks or dense foliage. The cuscus is hunted by humans in parts of its range, the meat being valued, and the slow movement making cuscuses relatively easy to catch, this hunting pressure threatening some populations, particularly in areas where forest is also being lost to logging and agriculture. The cuscus is mostly nocturnal, sleeping in tree forks or vine tangles during the day and emerging at night to feed, moving through the canopy with painstaking slowness that makes the animal seem almost plant-like, the cuscus proving that arboreal life doesn't require the acrobatic abilities of squirrels or monkeys, that slow and steady succeeds when food doesn't run away, and when predators can be avoided through camouflage rather than through speed. And now the nocturnal creatures fade behind your thoughts. We've drifted through 100 quiet truths about these animals of darkness. From the owl's silent wings to the firefly's gentle glow, from the bat's acoustic world to the hedgehog's spiny armor, from the fox's patient pounce to the pangolin's ancient armor, from the lemur's enormous eyes to the desert fox's cooling ears, you are connected to this world. The same darkness that awakens these creatures provides you with rest. The same moon that lights their paths shines through your window. The same night air that carries their calls surrounds your home. These animals remind us that darkness is not empty but full, that night contains as much life as day, that there are entire communities awake and active while we sleep, going about their business in a parallel world we rarely see. Tonight, as you rest, the nocturnal world continues its ancient patterns. Owls glide silently between trees, listening for prey moving through darkness. Bats navigate through 3 dimensions using sound alone. catching invisible insects with impossible precision. Foxes trot down shadowy paths worn by generations of paws. Fireflies write messages of love in light across summer meadows. Hedgehogs shuffle through gardens, investigating every scent and sound. Raccoons explore with sensitive fingers, learning the world through touch. Opossums wander unhurried through the night, playing dead when threatened but generally preferring to mind their own business. Flying squirrels sail between trees on outstretched membranes, masters of gliding flight. The nocturnal world pulses with activity we do not see. Creatures going about their lives in darkness, hunting and feeding and raising young, succeeding through senses we barely understand, and through adaptations refined over millions of years. And you are safe, warm, resting in a world full of wonder, where night and day contain different communities, where darkness reveals, rather than conceals, to those adapted to see, hear, smell, and feel what darkness contains. The nocturnal animals continue their patient work through darkness, each one perfectly adapted to its role, each one successful in its own way. The night being their time, just as day is ours, the planet being home to countless creatures, living countless lives. The diversity being staggering, the adaptations being elegant, evolution being creative beyond imagination. Sleep now knowing that while you rest, others wake. That the planet never sleeps but simply shifts between day shift and night shift. Life continuing always, the nocturnal world being every bit as rich as the diurnal world. Darkness being home to wonders that rival any daylight marvel. The night creatures being your neighbors sharing this world, living quiet lives in darkness, asking only to be left to their ancient patterns. These gentle, mysterious creatures of the night. If you're still awake, go ahead and watch the next chapter. Sleep well and dream softly. Good night.